Session number 4. That's where we are today. LangChain, we're talking production RAG today. So we're going to build on everything that we've learned so far, and we're going to make sure that we understand how to take the stuff that we've done in like a Pythonic RAG context and take it to the next level, take it to something that's truly production grade. But let's go around, see what's been happening in the community so far. I see a ton of amazing building, shipping, and sharing happening. So shout out to everybody that shared that I didn't catch in the AIE5 general channel last time. Shout out to Angres here. What is the vibe check? Indeed, indeed. Felix Ultima, Eric, Philip, tons of people. I love the shares where you're providing some extra juice here. Changing the prompt improves the LLM response. Love that. That's fundamental to everything that we'll do in this class. Deepali, Brickster coming in hot, NGO, Uma, love to see this. And then, really, as we start to see more and more people share, I'm going to start highlighting, as I mentioned, the ones that, I wanted to try all of the similarity, not just cosine similarity out. I'm going to start highlighting these ones. Deepali, Philip, Catherine, way to go. Vinod, love this. Cursor is amazing. Thank you for shoving it down our throats. Thank you, Robert Eubanks, for really starting this charge, actually. This is something that came out of actually teaching cohort 4, and we actually shoved it down the Wiz's throat. That's actually how it worked. And so here we are passing it on to you. How to use Cursor isn't something that only you thought was cool, Vinod. It's something that, people across the cohort thought was pretty cool. Hugh, love this. This is what I told a Polish developer who reached out to me today. Here's the suggestion. Take the projects and make a video, take the Loom link and put it in a prominent place in your project. Great advice, Hugh. But wait, hold on. What? Hugh, why are you saying do as I say, not as I do? I'm just kidding, Hugh. You did a good job on assignment 1, but keep it going with assignment 3. That's what we're looking forward to. Shout out to Kenny, who literally already finished the work from Tuesday and did the super advanced build. This was pretty cool because if you guys saw today, computer use from OpenAI came out, and I just made it a quick PDF, uploaded it to Kenny's app and was messing around. Learned that computer using agents now from OpenAI, they use perception, reasoning, and action. They use a reasoning action loop. We'll talk about that in session number 5 next time. And we also got together and shared what we were hoping to build for demo day. I want to point out a couple things here. Personalized coach, behavior coach, personalized assistant, personalized fitness. There's a lot of overlap here, and I really, really encourage you guys to jump into that post and start connecting with folks that have similar ideas. There's also a number of people that don't yet have projects. I encourage you to start reaching out to people, some virtual coffees, maybe over the weekend. This is going to be a great place. If you see people in office hours, it's a great time to grab them as well. Or maybe you can find them next week on Monday in the Build, Ship, Share accountability session we have every Monday. Maybe you can find him next week on Tuesday in Vincent's Deep Dives, where he'll be covering more on embeddings, semantic versus keyword search, and more on LangChain. And maybe they'll be on YouTube Live next week, where we're building, shipping, and sharing multimodality. You can find all your peer supporters all throughout the week. Go say hi. Ask them some difficult questions and see what's up. We listened to you last time. A lot of you guys loved it. Love that. Thank you. Concepts are finally settling. Beautiful. That's amazing. A lot of you guys getting a lot out of this. Pure gold. Like, wow, just incredible feedback. Not all of it's so incredible, though. More time going through the code. Wiz, more time. I told you guys we're going to try to keep it at a 7. We dialed it in today to really, really try to get as much juice as we can out of Wiz's coding time. See if you guys like it. Just way more time spent building in the breakout rooms. We've augmented today to try to do this to you. I'm going to try to get out of the way today a little bit more. It is a highly technical day. Hopefully you guys get a lot out of that. Can we get the pre-read at least a day before? We did this time, so hopefully our friends over in India and throughout the world got a little bit ahead this time. Hope that was better. I still feel like if we had received this earlier in the day, we could have asked more targeted questions. Please tell me more about what you mean by this, and I'd be happy to sort of explore more with you. We're not going to release the entire assignment. We do release the pre-work. If there's something in between, maybe we can meet you guys in the middle. Some additional suggestions. Chris's lightning speed has to be dialed down a bit. 7. We're going to keep it at a 7 out of 10. I can't promise you 7 from me today. I'm going to do my best. Material in the lecture, far less useful. This is super great feedback, especially the additional context. I say this for this session only, as it was our first build challenge. Definitely going to keep this in mind for cohort 6. Thank you for that. And then, one of the things was I thought it was in this repo, but it was in another repo. I wasted a lot of time. Hate to hear this. Wiz, why did you have 2 repos last time? Was there a specific reason for that?
Yeah, so this is one of the few assignments where that's true. Because we need to push the whole repo to Hugging Face in order to make that work. We have to have a separate repo. So we linked to that repo from the README. This is going to be true of I believe 2 more assignments as we go forward. I'll call them out very specifically again. But it's the idea that you should have a repository for this thing if in the case you're trying to just operate or launch that thing.
Yeah. And some other feedback on disconnects between videos and README files. I'd really love if you'd point out specifically what these disconnects are. We'll be happy to go in and update them, make sure everything's up to date. It's a constant battle out here on the edge. And then increase the size of the text in your command line instructions. I'm sure Wiz will note that. Also, I wish we could go deeper on RAG. You just wait. We've got a ton of weeks in store. We're going to start doing that today. We're going to keep doing that throughout the cohort. No problem there. Loved going through the code. Our peer support doctor is fantastic. Peer supporters are bae. This is some of the best feedback. We love getting this feedback. Please shout out your peer supporters today. And then the last thing is, I just want to make sure that you guys know we're still getting questions about where to find things. Wiz, can you show them if they're like, oh my God, I can't find anything. Where should they go? They should go to one place and one place only. They should go to GitHub and they should go to quick links.
Go to the quick links. That's right. So we will share the old screenerino here, and we will do exactly that. So you should be looking at GitHub. I'll zoom in a little bit. The idea is pretty straightforward. All we want to do is find out what, how to get to whatever. So the place that we're going to look for is in this aim quick links. We click on this. We see all of the sessions. So say, for instance, we wanted to know where the code for session 4 was. We just click on the link. That will take us to the code for session 4. We have links in each of the session readmes as well. That will take us to things like Notion. That will take us to things like our pre-work as well as our feedback. So we have all of these links. Once the session is done, we're going to populate the items that go along with it. So the recording will be there. As you can see, if we go back to the main quick links, all of the recordings are going to be in here. The slides are going to be in here. The homework form is going to be in here. So GitHub can be the one place you go, the central repository, classic GitHub of information, and that's going to be able to link you out to where you should go. So hopefully that's makes things a little bit clearer about how we organize things here.
I love it. Thanks, Wiz. And so if you're struggling, forget Notion, forget Discord, just go to GitHub and you can get your work done. Everything else is optional and additional and supplementary. All right, let's align our aim to the day. What are we talking about? We're talking about production grade RAG. we've picked out a stack for you. We're going to talk a little bit about why we picked out this stack for you today. We're going to talk about LangChain and the underlying core constructs, the abstractions you need to know. We're going to talk enough about LangGraph and LangSmith today to give you a little taste and, importantly, to align you with the state of the art in best practice building of production grade RAG applications and prototypes off the shelf right now. We're going to build a number of RAG applications today. It's going to be a blast, and you're going to see a little bit about how to use LangSmith. So we're going to talk about LangChain. We're going to build a naive RAG chain. We're going to learn about chains. We're going to build a simple RAG application using chains. And then we're going to flip the script and show you the best practice. Actually, we're going to go up a layer of abstraction, and we're going to use LangGraph to actually build a RAG application, just as you would find on the most recent updated docs from LangChain. So first, I want to talk about orchestration. Remember we talked about, the orchestration layer in enterprise and sending emails and all this kind of thing? Well, let's come down some layers, and we're talking about the orchestration of our applications when we build these solutions. We're talking about doing the AI engineering specifically with the application stack at the AI engineering level, not necessarily at the enterprise workflow level. We've talked about the LLM app stack. We've talked about that stack being based on in-context learning, and this is the fundamental design pattern. Remember, in-context learning came out of the GPT-3 paper in 2020, where they found, hey man, prompting, we just put it in context. It's pretty dope. We get really good results. The 3 stages, embedding, retrieval, and inference, this is the kind of thing you want to start teaching your team, wherever your organization is. This is the kind of thing you want to make sure everybody understands. And we can kind of look at the stack, and we're going to continue to break this up. Embedding, retrieval, inference. Today, the center, orchestration. LangChain really is still so hot right now. Now, we're also going to talk about this sort of logging and evaluation piece, the piece where you actually get logs. If you saw our YouTube event this week, we talked a lot about how we might evaluate agents. And the key way is you got to look at the logs. Well, where are we getting these logs, or where are we getting these traces? We're getting them during logging. And what we're going to build is we're not going to do this Pythonic end-to-end RAG that we did last time. We're going to forget about the front end and focus on the back end. We're going to do our logging with LangSmith. We're going to do our orchestration with LangChain, also LangGraph, and we'll talk about this in your breakout room. So Wiz, I want to ask you a quick question first. Why are we using this stack? Is LangChain actually legit? Because I heard it wasn't. And why Qdrant? Why OpenAI? Muted.
I'm muted. Okay, so yes, his LangChain legit. I mean, insofar as it works and it does the things that it says it will do, and it does those things in a timely, effective manner, yes. Why are we using this stack? Basically, because it will scale with you from the stage we're in now, which is kind of very prototypey, into a reasonable production. So if you're going to be at enterprise level with millions of active users per month, you might notice that there is some latency issues with this kind of stack from the, basically from the LangChain side, the way that we're going to implement the prototypes, but that's expected. And so until you reach that point, the stack is going to be extremely well suited to you. The reason we're using Quadrant is because it will scale into many, many gigabytes of vectors before even pretending to slow down. Mike C, I believe, shared a blog post where Quadrant is also going to, add some GPU support, which means even faster vector processing, though it's going to cost a little bit of extra cash. And then the reason we use OpenAI is because OpenAI's APIs are decent. They're usually up, and they are they have a lot of well-costed models. You can easily substitute your favorite LLM here, right? Like if you're like, I only use Claude, I only use Cohere, it's a one-liner to change these things. And that's a big reason why we use LangChain.
Yeah, I heard Claude was cooler now. And so maybe some people will do that. Also, LangChain they got funding the earliest. They've been out in front the longest. They've been doing this now for as long as we've been teaching it. So shout out to LangChain for getting after it. Also, Quadrant, not Quadrant specifically. It's spelled that way, but it's pronounced Quadrant, is the latest vector DB company to actually get funding. A lot of them got funding a long time ago and kind of have petered a little bit. They are really still kind of shipping and really making moves. So shout out to LangChain and Quadrant for the work that they're doing. As we'll see, these are kind of best practice tools. You can talk more about that with us in office hours or peer supporters later. Let's talk LangChain. Harrison, the CEO of LangChain, talks about the real power coming when we combine LLMs with stuff. A classic thing for the CEO of an orchestration company to say, right? But also true, importantly. LangChain now has become so meta that they just say we're a framework for developing applications powered by LLMs. AI powered, baby. They used to say, and you'll still find this in their docs, LLM applications that leverage context and reasoning. This is getting more interesting over time. We'll see this and talk more about reasoning when we talk about agents. And really, they're trying to cover you full end-to-end across the entire life cycle. So during the development prototyping phase, making it production grade even during that phase, so we can scale to millions of users, and then also actually doing the logging, the LLM ops, and tracking the stuff in production. And then recently, they've launched LangGraph platform, where this is something that you can actually do on-prem. You can do it in their LangGraph cloud. You can do it everywhere, and they're moving more and more end-to-end. So January last year, they released V0.1. So they were like, no more breaking changes. We got core. We got community. We're going to get after it. We're serious. Now, they talked about a lot of stuff. We're going to talk about two particular things today. We're going to talk about composability with LangChain expression language, or LCEL. We're going to talk about retrieval, obviously, RAG. Now, V0.2 came out in May. They kind of got this full separation, some other little stuff, and more tool calling, more agentic stuff, as we'll kind of see. V0.3 came out in September. Not a whole lot going on there. What are they working on? Improving multimodal capabilities now during this, and we'll see what they do next. So what we want to talk about today is we want to talk about the steps that we need to accomplish RAG. We already know about RAG. Let's talk about LangChain. If we want to do a simple chain, what do we need to know? Well, we need to know what the core components are that we can actually work with and what these constructs are in LangChain. A simple chain is going to leverage LCEL, LangChain expression language. It's going to leverage models and prompts, and it's going to leverage chains. So this is the key thing. What's a chain? It's just a sequence of calls to other components. Now, this is not the primary abstraction. Think of a chain. Think of like this chain. Now zoom in. What is the chain made of? It's made of little pieces of chain links. We can think about the actual primary abstraction in LangChain as the links of the chains. These are called runnables. These are at the core. Whether we build chains, whether we have nodes in our graphs, as we'll see later, or entire graphs themselves, these are all runnables. Runnables provide a universal interface to take an input, to do some operation, to provide an output. These are the Lego blocks. We combine the runnables in flexible ways, just like Legos. How do we do that? Glad you asked. It's with LangChain expression language. This is a declarative way to easily compose chains. We can do it in this beautiful little bar right here. And the first chain we're going to build, we're going to put together a prompt, and then we're going to put it with a chat model. What's the model like? Well, we already talked about system user assistant from OpenAI. In LangChain, we call this system human AI. This is our chat model. So we can set up a chat model and connect it to a prompt. We already talked about prompts too, right? What's the prompt say? Well, you guys messed with this already with your RAG application. It says something like this. It says, yo, don't lie to me and hallucinate like you would out of the box. And so the simple chain gives way then to building a simple RAG application. Our first chain is simply this. What else do we need to chain to build a RAG application? Well, let's go back to the constructs. We need to know how to split text, text splitter, and how to use an embedding model. Hey, we already know about that stuff. Text splitter, remember chunk viz, remember text splitting. We talked a little bit about this recursive character text splitting. You take a closer look at this today. We talked about embedding models. Remember, we talked about word to vec. We've been using text3 embedding small. You can look at open models. So a naive RAG setup is literally just prompting the context, like copy paste into the context window. Wiz will show you how to do that with LangChain, super easy. But more interestingly, if we want to do a simple RAG application, add quadrant, remember what we're doing. We ask a question, we go look in our data, set up the prompt template, return the reference material. That's retrieval. That's in context learning. RAG is almost complete. We still have to put it into the chat model that we've set up with our prompt chat chain and then get our answer. So if we think about like the way we're going about doing this, we're going to build it up layer by layer from Pythonic RAG. The LCEL chain constructs are then added to the naive RAG constructs, are then added to the retriever, the document loader, and the vector store constructs in LangChain. So we can take our RAG and we can add the pieces. We can glue everything together with LangChain, put the embedding model, put the text splitter. We can add then the retriever, the vector store, the document loader. And all this is exactly what you think it is. Document loader, what do you think it does? You guessed it, loads up those docs. Vector store, what do you think it does? You guessed it, stores those vectors. And we already mentioned we're using quadrant. It's pretty dope. Check it out, scales well. The retriever, we talked about retrievers. Similarly, this is also an interface. It's the wrapper for the vector DB. It's built into LangChain. So we can actually look at all these pieces. We can pick them out. What we're going to do is we're going to take some data. It's going to be the data on LangChain expression language. So we're going to get kind of meta here. We're going to chunk it up. And we're going to run it through our embedding model. We're going to set up our RAG pipeline. We're going to make sure that our chat model is at the end of it ready to go. So remember, naive RAG is literally prompting the context. The LangChain RAG is about chaining all of the pieces together, gluing them together with LangChain. Each of the little pieces of the chain, the links in the chain, these are runnables, the primary abstraction. And so we're going to go 1, 2, 3 steps in one shot. We're going to take a big old step here. Wiz is ready to walk us through it. Show us how it's done, Wiz.
Oh, yeah. Okay, so this is the intro to all of these things. It is going to be a lot of stuff in a row, but it will be worth it at the end. So I'm gonna go ahead and replace the share here. We're gonna start from our quick links. We're gonna go to session 4, production RAG, and then we're gonna navigate to the notebooks. If you're using this in your local environment, please be sure to use UV to sync the .venv. And if you're not using local, though we would prefer that you did, you can click the Colab link, which will take you to the assignment. So the idea of this first breakout room is pretty simple. We're gonna do all of these things. Now, this looks like it's a lot of things, but it's not really a ton. It's just kind of using what we learn in one step in the next step. All right. So the first thing you're gonna need to do is get all of your dependencies. If you're doing this locally, this will have already been handled by UV. If you're using Colab, you want to run this pip install. You'll notice that LangChain is a package, LangChain Core, LangChain Community, LangChain OpenAI. You get the point. We get to pick and choose what LangChain flavors we need depending on what we're doing. You'll see that because we're using Quadrant, that we have LangChain Quadrant. We also need the actual dependency from Quadrant, which is Quadrant Client. And then we're going to have Tick Token and PyMu PDF for funsies. We'll use those very sparingly later on. We're going to set our environment variable. So this is a pattern that you're going to see constantly throughout all of the assignments. We need to provide our API key to OpenAI. Without it, we can't run models, so you just have to provide it. And then we're just going to start with a simple chain using LCEL. LCL, LangChain Expression Language, right? Greg was talking to us about it. The idea is it's these little pipes that we're about to see. And that's what it comes down to. We need some kind of a model, right, in order to begin. We're going to use Chat OpenAI model, which is a chat model, and it is from OpenAI, of course. We're going to use GPT-4o Mini. The reason that we're using 4o Mini is because it is cheap. It is also incredibly effective at very straightforward RAG tasks, which this is absolutely. You can ask the question, what other models could we use? And this is going to be answered, by looking at this page. So I won't click it here, but if you look at this page, it's going to tell you the answer. So that's the model. Now in Python, we just used the OpenAI, API. So we created an OpenAI client, and then we use that. This is basically just wrapping that, but in a way that LangChain finds to be useful because it's a runnable. And you're going to hear me say because it's a runnable about 15 times in the remainder of today's session. The next thing we're going to do is set up a chat prompt template. We had this in the Pythonic implementation. It works basically the same. We're going to have some system template, and we're going to have some kind of human template, and we're going to use from messages to create a chat prompt. Now, you'll notice that this template set only has one fillable field, right, which is going to be content. So that's going to be something we can add things to. And you'll also see that it says human, right? So this is a point of LangChain. Instead of using user, it uses human. That's the big difference. As well as instead of assistant, you're often going to see AI message. Those are the differences. All right, so now, how do we make chains out of this stuff, right? So we got a chat prompt. Okay, that's dope. And we have a model, but how do we make our chat prompt talk to our model, right? And that's what we're going to use this pipe or LCL for. This is how we make a chain. It's very straightforwardly, you can think of it as the left side is chained into the right side, right? If you're familiar kind of with the terminal, the left side is piped into the right side, something you might be used to. This works because this chat prompt is, you guessed it, a runnable, right? So the idea is that all runnables have some consistent kind of input and output schema, and they're able to be attached based on that input-output schema. So for instance, chat prompt is going to it's going to output messages, and OpenAI chat model is going to accept as input messages. One of the things that's useful about this runnable pattern is that if you do something obviously wrong, LCL will complain about it, right? If you try to chain two runnables together that don't go together, LCL will produce an exception, which is nice. All that's happening at the end of the day is that we now want to invoke this chat prompt. So the way we think about chains, or any chain of runnables, or any runnable, to be clear, is that we invoke them. So this is basically like run, except very, very slightly different. So we use the term invoke. basically you think of it as run. Now you might say to yourself, well, how would I run this or this? It's still with invoke because the chain is itself a runnable, right? So once we chain these two runnables together, the resultant object is as well a runnable. So isn't that great? The idea is we can invoke this on this dict. The reason that we're providing this dictionary, right, with key content is because we know that our template that we created has this formatable chunk, right? And that's going to be how we format that piece of information. So this is how we inject that. If we pass that without content, it wouldn't know what to do, right? The runnable is expecting that we provide content. That's what's in its expected input. So we use content, and then we pass in just whatever string we want. In this case, it's got to be hello world. And then we have this, greetings, seeker of knowledge, and curdled delight. I see you wander in the realm where mozzarella dreams, blah, 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 blah. The system prompt is that this is a wizard that talks about cheese. And so that's why it did that. Next, we can use the same chain and invoke it on different content. Classic. So what we're going to do is we're going to say, can I please have some advice on how to become a better Python programmer? And we have, of course, seeker of the arcane art of Python. Heed these riddles, spun from the curds of wisdom, aids in the cask of experience. The Gruyere of fundamentals, right? It's cheese puns. We get it. But this is the idea, right? It's the same as what we saw in Pythonic RAG, except this time we don't have to use Pythonic RAG. Okay. So that's that. So how do we build like a very naive RAG chain? Very naive here meaning that we straight up manually provide the context, right? So the worst version of RAG with LangChain, well, it's pretty straightforward. Once again, we're going to build our chain. Our chain's going to be a little less of a silly system prompt this time. We're going to say you are a helpful assistant, and then we're going to have the formatable content for our human message. We're going to create a chat prompt. The chat prompt is going to be from messages, a system message that says you're a helpful assistant, and a human message that says content. Then we can invoke this chain just as we did before, and we can ask it to define LangGraph. As my last update, LangGraph is not a widely recognized or established term within the fields of computer science. Okay, interesting, right? So it just doesn't know about that, but we know LangGraph exists, and spoiler alert, we're going to use it in a notebook, right? So what we want to do is try asking another question, right? LCL's been out for a while. What is LCL? We get like a closer answer than we did the last time we ran this, but it is not correct. It tries its best. It confidently makes something up that is wrong. So we've already found two problems here, right? The model doesn't know about stuff that was released after it was trained, and the model confidently lies about things if there's no context to ground it. So we know already that the answer to this is RAG, right? This is something that RAG can help with. So what we're going to do is we're going to create a new human template that's going to have context and query as something we can format, and we're going to say you use the provided context to answer the provided user query. Only use the provided context to answer the query. If you do not know the answer or it is not contained in the provided context, respond with, I don't know. Or in classic misspelling fashion, response with, I don't know. The model is smart enough that doesn't brick it. Okay, and then we're just going to manually paste in a blob from LangChain's docs. This is just going to be explaining what LCL does. There you go. And then we're going to format this into a prompt. We're going to create a chain. And then we're going to query the chain by passing in, when we use our invoke, we're going to pass in both query and context. And again, the reason we need to do this is because human template expects query and context, which means that this chat prompt runnable has an expected input of query and context. And because the chat prompt is the first thing in our chain of runnables, when we call the runnable that is that chain, we need to provide it the expected input. There you go. Okay. There you go. So now we get LangChain expression language is a declarative way to compose chains, blah, blah, blah. It's basically just repeating a lot of what was in the blurb that was pasted in, but that's ideal. That's what we want, right? We want the LLM to tell us about what was happening. All right, so that's very naive. We don't want to paste in information all the time. That's tedious. That's not ideal. We want to build a system that's going to automatically fetch us information like we had with Pythonic RAG. And so that's where we get to just implementing simple RAG using LCEL. Very cool. Very happy about it. Okay. Now, when it comes to RAG and LangChain, the first thing we need to think about is retrieval. We've done retrieval already, right? We built in a vector database in Python. It was simple, but it was a vector database, or what we're gonna learn today is a vector store, more technically. But the idea is that what motivates needing this anyway, right? Because you can just post all of the stuff at once into the LLM, right? Well, this is where we look and we see, imagine we had pasted in every single Hitchhiker's Guide to the Galaxy book, right? This is just for demonstrations. So you don't have to run these cells. You certainly don't have to paste in every single Hitchhiker's Guide book worth of text, but there's 898 pages of available material. And then we can count how many tokens occur, and we see that there is 636,000 tokens. In even the largest OpenAI model is going to be sad about that, right? So you could use something like Gemini Flash, which has up to 1 million, tokens in the context window. But again, this is just one series of books by one person, and it's already at over 500,000 tokens, right? So we can imagine that context window is a limit. And that's what motivates RAG. That's why we do this chunking thing, right? Because we don't want to put in all the information at once into the context window. And in fact, we find through research that that's not a good idea. It harms the performance of the model if we do that. So this is why we have chunking. Now, we built a very naive chunker in Python that split things by just the number of characters. However, what we're going to have instead is we're going to have the recursive character text splitter. This is going to split things a little bit more intelligently. So it's going to use some heuristics to split things first by double new lines, then by new lines, then by spaces. The reason this is useful is that a lot of the information that we're going to put in is going to be things like PDF reports, text, information, books, blogs, these kinds of things. And for those kinds of data, these are a great way to think about how information is logically grouped, right? First by paragraph, then by chapter, then by sentence, right? So this is the idea of something like recursive character text splitter. It helps us keep as much information together as should be single coherent thoughts. And this is something that you're going to discuss with your group about, potential pitfalls. The way that we actually do this is easy. Thanks to recursive character text splitter, we set up a thing that counts tokens. So we can do this because TickToken has a path to count tokens the same way that GPT-4o Mini does. And then we simply create our recursive character text splitter. We're going to say each chunk should be 100 tokens. There should be no overlap between chunks. And the length function, the way we calculate the length of the chunks, should be done with this TickToken length. Then we're going to take our context and we're going to split it into chunks. The context, just to remind you, is a paste of the LCL blog. And we're going to go ahead and see our chunks here. We have 3 chunks total, which is not a lot of chunks, but such is the idea. You can see these separated out here if you want to. There you go. Okay. There is an activity. The activity is basically, why is this chunking strategy not necessarily the best? Just brainstorm with the group quickly, slap down some ideas. We're going to get real deep on this for the rest of the boot camp, but start thinking about, like, how would you chunk data, right? Because it's different for every kind of data. Okay. Then we have our embeddings and dense vector search. This is the easiest. This is the most straightforward part. We take OpenAI embeddings. and then we point to text embedding 3 small. Good stuff, just like we did in Pythonic RAG. What is the embedding dimension of text embedding 3 small? You can look it up in the docs. You can write some code to find out. At the end of the day, you are going to have to fill in this value. The notebook will not work if you don't fill in this value, and it should be correct. So please make sure that you fill in this value, or else the notebook straight up won't work, right? So we need to store these vectors somehow. Before we were just storing them in a dictionary. Obviously, that's a terrible idea if we have more than 100 to 1,000 vectors. So instead, we're going to use quadrant. There's lots of reading you can do about quadrant in the notebook, so I'll leave that to you to do as you work through it. The basic idea is that we're going to set up an in-memory quadrant client. In-memory just means that it's going to be stored in our RAM, so our system memory. It's not going to be persistent to disk. And it's not going to be stored through some kind of database. It's just going to be straight up chilling around in RAM, which is not a great idea past prototype. But the way that we would change this for when we move to production is simply modifying where it points to. So thanks, Quadrant, made it nice and easy. We're going to create a collection. A collection is a subset of vectors in our vector database. Basically, you can think of it as like its own table, is an analog. We have to create a collection, and we have to define what our vectors look like. So this is why we need to fill in that cell earlier, and how we measure distance between, or how we consider distance between vectors. Very cool. Okay, then we have the actual setup of our vector store. This is called a vector store. It's technically a vector database. There is some differences. You can read about them through links in the notebook. We need to provide our client, our collection name, and the embedding model. Then we just add texts. Easy. Let's go. In order to create a retriever from our vector store, extremely straightforward. We use .asRetriever. We're going to see .asRetriever a lot, and we're going to be able to specify, K many documents that are retrieved every time we call this. Okay, cool. Then we're going to put this all together into one chain. And here's what we do. We're going to use this runnable pass-through and string output parser. These are some special LangChain, tools. But the idea is for our simple RAG chain, we're going to start with this dictionary. The dictionary is going to have key, context, and query. We are going to populate context with the result of retriever as called by the input to our chain. And for our query, we're going to use this thing called runnable pass-through. All this does is it says, okay, we are going to just have this thing populate here. That's it. So runnable pass-through just means it just passes on through. It's not really doing anything, but it's a way that we can indicate we want you to take what was given to this as input and exactly send it out as output. We're going to chain this blob, this nice little dictionary, into chat prompt, because chat prompt expects, you bet it, context and query. We're then going to chain that into our chat model, which is going to be a list of messages. And then we're going to chain our OpenAI chat model response into a string output parser, which is, I'm just going to say the words in a different order. It's going to output the response as a string. Very cool. Very, very, very neato. So we get this nice string instead of a big ol' ugly looking blob. Don't worry, we will deal with big ol' ugly looking blobs for the rest of the boot camp, but for now, we get a pretty string. And that is it. We have a final question, which is why is LCL reliable at scale? And spoiler alert, you can use this simple RAG chain that you built to answer the question. There is also a note on runnables, so you can read about runnables if you'd like to do a little bit of a deeper dive in the notebook. That's available for you offline. There you go. With that, I will send you guys back to Greg, who will get us into the old breakout arenas.
So is that all there is to it, Wiz? Just a quick little demo there on RAG. It seems pretty straightforward. Seems to connect to what we did last time. It is a lot, right? But it's going to keep coming together. It's going to keep coming together. Thanks for walking us through that, Wiz. And we are going straight to breakout rooms. We're going to spend 25 minutes. We're going to take a break a little bit late today. Hope that's all right with you guys. 25 minutes, We're going to use simple chain, naive rag with the prompted context, simple rag using LCEL. If you're freaking out and you still don't have your basic setup done, join this room for support to get some one-on-one help from Todd and Duke. Otherwise, enjoy the time in your breakouts. We'll see you back in 25 minutes, guys. Back from break. Hope you guys are ready. It's time to talk just a little bit about LangGraph and LangSmith. Okay, LangGraph. What you need to know today is that LangGraph creates state machines by specifying them as graphs, LangGraph. What you need to know about state machines is that they help us track state. Just what's happening right now. Remember the little runnables, the chains? What's coming in? What are we doing? What's going out? That's kind of like state. LangGraph is really cool because if you can draw it, like your product team can draw it, your engineering team can build it. That's super dope. Now, today, what we're going to do is we're going to actually do a flow that is acyclic. Remember the old DAG, the old DAGarino? We're going to do a DAG today. We are not restricted to DAGs. We could do cyclic ones like DCAGs, or there's no cool acronym. We're going to talk about this when we talk about agents next class. Either way, we're going to use graphs. Graphs have nodes and edges. The nodes are the runnables. We'll talk about tool calls later. The nodes are the runnables. The chains are the runnables. The graphs are the runnables. Runnable, runnable, runnable. The edges tell us where to go based on the state. Where do we pass our state next? Okay, that's enough. LangSmith is going to allow us to, as LangChain tells us, get your LLM app from prototype to production. Okay, great. It tells us also that it's an all-in-one developer platform for every step of the LLM-powered application lifecycle. Okay, great. It tells us, my favorite, LangSmith turns LLM magic into enterprise-ready applications. Tell this to your stakeholders. What's really going on? Well, there's two things. One of them is evaluation. There's a lot of evaluation tools built in. As we improve stuff through metrics-driven development, where we establish a baseline, we change some stuff, we recalculate, kind of like what Philip was just talking about. We can do this with LangSmith. We can do this through different evaluators that are baked in, that really are simple prompts behind the scenes. Question answer evaluators, different criteria. We've started to allude to some of this already. Question answer evaluators, we'll talk more about this later, but is the answer correct? We're going to go deeper into this as we talk about the RAG assessment framework and other evaluation frameworks that are a little bit more best practice, but you can do a lot of this in LangSmith, and they integrate also well with RAGis. You can also see a criteria evaluator. Accuracy. How accurate is this prediction on a scale of 1 to 10? Literally, prompt the LLM, ask it to assess it, no other context. This is a criteria evaluator with no other context, without any labels. If you wanted to add some labels, you wanted to add some additional context, you can. How accurate is this prediction? Oh, this one. Compared to the reference, oh, this one on a scale. Maybe that's going to be a little bit better. We can do custom ones. You know, we like to do dope or nope. Is it lit? Is it hype, etc. Okay, the other piece besides evaluation is visibility. And this is really, we need to be able to see what happens inside, especially when stuff goes wrong. So the trace is the thing that allows us to do this. It's going to run through our graph, right? The runnables will make runs through the graph, and the runs, all taken together, kind of provide our trace. And the trace is what we can use for evaluation. What went wrong at what spot? Did it go right? How right did it go? when we talk about best practice RAG, as of this cohort, best practice RAG, not sure why this isn't showing up. I'll just show you straight up directly. If you go to LangChain, it will tell you to go ahead and use LangGraph. We now have the prerequisites to understand how to use LangGraph, why we might want to use LangGraph, and how to build a beautiful little graph that looks something like this. Wiz is going to show you how to do this, and also if you get done early, you want to go advanced into LangSmith, there's a notebook available he'll give a nod to as well. Wiz, over to you.
All righty. Yes. Thank you, Greg. So, LangGraph. Again, we're just going to start from the repo. We're in our repo. We're having a good time. And what we're going to do is we are going to go to our quick links, and then we can go to session 4 code, and then we can launch our code in Colab if we want to, or just locally, depending on how you're doing it. The easiest thing to do with LangGraph is just get into it. So we've got a bunch of reading for you if you want to do some reading. The idea, though, is that we have some state, right? This state is what we pass around the graph, right? So you can think of the state as just being exactly what it looks like here, a list of things. We're going to keep those things updated. We're going to make changes to those things. At the end of the day, all the graph does is it acts as a way to move this state around different nodes that are going to modify it, right? So like a node will take in state, and then it will return state, and then edges will connect that state from one node to the next. That's all it's doing, right? So very, very straightforward. We got a little sample of how this works, right? We start off with our state object. It's got nothing in it. When we invoke it, we add a question, right? We get this query now, questions filled out. Then we pass it to the node that's going to do work. It's going to fill out some context, and it's going to provide a response. Easy peasy. Okay, so how do we actually set up the state? It's very straightforward. We're going to use a typed dictionary. We're going to use question, which should be a string, context, which should be a list of documents, and response, which should be a string. We're just going to call that bad boy state. A simple graph is just like this, right? We have nodes that are connected by edges. They do stuff. You'll see here that we have a cycle. This is a valid graph in LangGraph because it supports cycles. However, today we're just going to not worry about that as this is our first introduction to LangGraph. Okay, so we have state. That's very happy. Now we need to do something with state. Yes, dag nabbit, exactly. Okay, so we'll need to build some nodes. You'll notice that these nodes are looking an awful lot like Python functions. And indeed they are. LangChain will treat them like runnables, but what they are is just functions that take in state and they return state. Very good, very good. You'll notice that we return modification to state, which is very handy. We can actually interpret how to deal with this in our state. We're not going to do this today, but we will do this in the next session. We can determine how these objects respond to modifications, which is very, very fun. So this is just going to take in our state, and then it's going to invoke our retriever on the question, which is going to produce a list of documents, which we will return to state. Very happy. We're going to do the same thing with generate, where what we're going to do is we're going to take our chat prompt, we're going to chain it into our model, and we're going to chain that into our string output parser. So we're building a little LCL chain here, right? We've got some runnables inside our runnables now. And then we're going to invoke that generation chain on the user's query, which we pull from state question, and then the context, which we pull from state context. We then return modification to state, which is going to be response. So now we have two nodes, and these nodes do things. What we need to do next is create a graph, add the nodes to the graph, and make sure that everything's plumbed up correctly. We're going to start with just a blank canvas, which is going to be our state graph, which has our state object. We're then going to add a sequence. Add sequence is just going to add all of the different nodes we provide in this list, and it's going to connect this node to this node, which means that this node will be sending information to this node. So state will come in to this node, or technically not yet, but when we plumb it up correctly, state will come into this node and then get passed to this node. If there were 50 elements in this list, you can imagine that generate would then connect through an edge to the next one, and so on, and so on, and so on. It just builds a big, long, chain, as it were, of nodes. However, we don't actually have a way for state to, and just to be very clear, the last node is going to be automatically connected to end, the end node. That's because every single graph has a special set of nodes called the start and the end nodes. They do what they say on the tin. What we're going to do, though, is make sure that we can get into this sequence. And the way we do that is by connecting the start node to our retrieve node. So basically what we've done is we take our blank canvas, we plop down 2 nodes on it, retrieve and generate, and then we connect start to retrieve. That's it. Then we can compile the graph. Compilation is important because it's going to do some very cursory checks for us. It's going to make sure that everything's working the way that it should. Thank you to compile. We can visualize it with this mermaid plot and see that we go from start to retrieve to generate. What a good day. And then we can invoke this graph because, yes, the entire graph is also a runnable, right? So this is going to become very useful when we start talking about crazy things like multi-agent, right? The fact that a whole graph is itself just a runnable means we can interact with that very easily. Okay, that's it. There's a question here. The question is going to be a little bit of a discussion with your breakout room. Nice and straightforward. We also have it available to you, though we're not going to work through it together. We're going to spend a lot of time on LangSmith. Don't worry. We have an entire notebook dedicated to LangSmith, walking you through how to use LangSmith as a visibility and monitoring tool, as well as doing some evaluations of basic LCEL chains. Basically, again, you can just get that from the notebook, and I'd recommend working through this. It's not necessary, it's optional, so you don't have to do this for an assignment, but I would very much encourage you to work through the notebook, learn a little bit about LangSmith. Evals, you'll be surprised that all you need to do in order for this to work very well is a few very simple imports, which is always fun. As I doom scroll past all this incredible information, you're going to see this is all you really need to do to get LangSmith up and running, which is very little at the end of the day. All right, with that, I'm going to pass you guys back to Greg, who will get us into our breakout rooms.
All right. Nice. Let's go, Wiz. All right. So we got a lot going on today. And, there's a whole lot for you guys to potentially chat about in your breakout rooms. We covered LangChain, a little bit of LangGraph, talk more about it when we talk about agents, optionally LangSmith. And so we really do have an opportunity to get a nice, robust ecosystem of tools starting to feel production grade and end-to-end today. Remember, every chain is runnable. Every node is runnable. Every graph is runnable. And we can start to even think about building graphs that are within other graphs, right? And we can get very, very meta with this. So have some great discussions, learn a little bit about LangGraph, take it where you want to take it with your peer supporters and your journey groups. Enjoy the time together. We're going to open them for 25 minutes, if we could, and then we'll come back and we will close it out. Week 2. Hope you guys have a great time. See you soon. Up. All right, so we learned a lot today. We covered a lot of ground. We will keep going deeper on LangChain. We will keep going deeper using runnables. We will keep going deeper, turning flowcharts into apps, directed acyclic, directed cyclic. We'll keep evaluating our applications If you didn't get to that today, no worries. We're going to pick up right where we left off with LangGraph and LangSmith. Next time, we're going to introduce agents, and we're going to really dig into LangSmith a little bit deeper. For those of you that want to take it a little bit further, we've got some stuff in store for you as well. Don't forget, homework 3 and 4 are due next Tuesday. Don't forget to build, ship, and share. And it's about time for some feedback. You know what time it is. Last 2 minutes. Let us know what you thought, and we'll go ahead and close it out, putting 2 minutes on the clock right after the 2 minutes for feedback is up. Thank you in advance, everybody. If you have questions, please throw them in the chat so we can be nice and quiet during feedback. Thank you so much for joining us for session 4 and for providing feedback. It really does mean a lot. We will continue to do our best to improve. Don't forget to join us on Monday, first thing, if you're on Pacific time zone, 9 a.m. PT. I'll be leading the sesh. This is in the public Discord. Mike C will be breaking down exactly what's going on in Silicon Valley and around the virtual world with regards to AI. You'll hear what others are building, shipping, and sharing beyond the cohort, and it really is a great time and a great group. Don't forget, before we meet again, Vincent's deep dives will happen on Tuesday. You can find him next week talking deeper about embeddings, deeper about a lot of the stuff we've talked about since session 2. You can find us next week talking multi-modality, and you can find peer supporters, including the Wiz himself, tomorrow and in office hours over the rest of the week and through the weekend. Thank you again so much for joining us. As we come to the end of our second week, I really do want to give a special shout out to everybody that's really participating and that's really putting a lot of effort and work into this. We know that this is a serious effort for many of you. This is a boot camp, and you guys are taking it really seriously, and it's really, really making an impact on the people you're working with and on the peer supporters leading your journey groups. Thank you for giving AI Makerspace a chance. Thank you for being one of our early adopters. We hope to continue building the world's leading community for people who want to build, ship, and share with you. You guys are some of the core foundational pieces, and I can't wait to see what you build, ship, and share this week and in many of the weeks we have ahead, all the way up to demo day. Have a great weekend. I'll see you guys soon. Ask on Discord, tag us on LinkedIn. See you guys on Monday and see you on Tuesday. Bye, everybody. Have a great weekend, and we'll see you real soon.
Bye, everybody. Take care. Have a great weekend.
Bye, everybody. Bye.
Right.
Bye.
Yeah.
Later, guys. Have a good evening. Have a good night. Have a good morning.